Let's try another greatest common factor question. Here we're dealing with these polynomials with numbers and different variables and different exponents. First, look at the number 16, 8, and 6. What number can we pull out? We start with 2, sure. 3, no. 4, no. And as you go up higher and higher, you realize that 2 is the only number that you can pull out here. So I'm going to pull out a 2. Next, look at the x's. Which is the x with the highest exponent? It's x squared. So right away I know the GCF is going to involve x squared. Now what about y? So the exponent we chose is actually the x with the lowest exponent, because for sure we can pull out an x squared out of here. So what about the y? Which is the y with the lowest exponent? It's going to be y to the 1, which is y. So this here is our GCF. And you can see that GCF is very closely related to factoring, because if we were asked to factor this, or what if we had a nice expression such as follows. We had the expression 16x 5y plus 8x cubed y squared plus 6x squared y cubed, and we were asked to factor this. In that case, we'd have to pull out the GCF. And so, because we already computed this should be a bit easier. So we factor it as follows. We have the GCF pulled out. 2 times what is 16? 2 times 8 is 16. X squared times what is x to the 5? It's going to be x to the 3. Since when you multiply two variables, same base, we add the exponents. And then how do we get a y here? Times 1. So I'm just going to leave this alone, and this multiplied becomes this expression here. So we have a positive sign here. 2 times what becomes this? It's going to be 4 x y, because x squared times x is x cubed, y times y is y squared, plus 3 y squared. 2 times 3 is 6. The x squared times 1 becomes x squared. Y times y squared is y cubed. So you can see that the GCF and factoring are kind of similar ideas. They're closely related.